Here's the truth about rebuilding a Bugatti Veyron, no matter how much money you throw at it, no matter how many former factory engineers you bring in, no matter how many impossible problems you actually solve, this car will find a way to break your heart at the exact moment you think you've won. Maccan just found that out the hard way. Months of work. Nearly £500,000 invested. A team of people who have forgotten more about Bugatti engineering than most mechanics will ever know. And in the span of a few seconds, on what should have been a routine drive, all of it teetered on the edge of collapse. Not because of a mistake, not because corners were cut, because of one component that nobody could test until the car was actually moving. And by then, it was already too late to stop it. But here's what the headline doesn't tell you. Before that moment, this Veyron fought back against everything. A misfiring engine nobody could diagnose, a gearbox hiding a secret, a rear wing that flat out refused to cooperate, critical parts that Bugatti point blank refused to sell to anyone outside their approved network. Problem after problem that should have permanently ended this project, each one somehow solved, each solution more creative than the last. This car came closer to the road than anyone thought possible. And then it chose the single worst moment to remind everyone exactly why Bugatti builds these cars the way they do. Start at the beginning. Because the clutch failure only makes sense once you understand everything that had to go right before it went wrong. The first crisis had nothing to do with the gearbox. It had nothing to do with the bodywork. It was the engine, and it wasn't misbehaving politely. This 10-cylinder, 1,000-horsepower machine was misfiring with a violence that made it feel fundamentally broken. Not a gentle stumble at idle. A full-blown, unpredictable, full-throttle shudder that turned every start attempt into an event. Diagnosing a Bugatti Veyron is not like diagnosing a normal car. These machines were engineered in secrecy, built in exclusivity, and maintained almost entirely inside Bugatti's own network. The diagnostic systems are proprietary, the data is locked down, and the manufacturer has made it perfectly clear they have no intention of helping anyone who bought one of their cars and didn't bring it back to them for repairs. So Mark did something that required both patience and access most people simply don't have. He tracked down a healthy, fully functioning Veyron and put the two cars side by side. Same engine architecture, same sensors, same everything. And then he watched the live data. The difference showed up almost immediately. The mass airflow sensors on Mark's car were reading completely out of range. Those sensors measure the precise volume of air entering the engine. Get that reading wrong and the ECU can't calculate the correct fuel mixture. The misfire wasn't mysterious. It had a source. It had a fix. And here's the part that reveals everything about Bugatti's strategy. Those sensors are not exclusive Bugatti components. They are shared, quietly and without public acknowledgement, with other vehicles in the Volkswagen group, which means they can be cross-referenced. They can be independently sourced. They can be replaced without ever contacting the manufacturer. Matt Armstrong discovered exactly the same thing during his own Veyron rebuild. The same misfire, the same sensor, the same solution. So Bugatti won't sell you the parts, but they'll use the same parts as a mainstream production car. Think about what that tells you about why they won't help independent rebuilders. Misfire solved, one crisis down, and immediately, a new one appeared. The rear wing on a Bugatti Veyron looks like an aerodynamic feature. It is, but that's almost a secondary function. The real job of that wing during lower speed testing is to open a channel that allows the engine's exhaust heat to escape. Run this car at any meaningful speed with the wing locked in position, and that heat builds up fast, in components that cannot be easily replaced, sourced, or repaired. The wing sensor had failed. The wing wouldn't deploy. And Bugatti, completely on brand at this point, refused to supply a replacement. Which is when Chris arrived at a solution that genuinely deserves more credit than it typically gets. He used magnets. Precisely positioned magnets that fed the Veyron's ECU a signal consistent with what a functioning sensor would produce. The computer detected exactly what it expected to detect. The wing deployed. The heat channel opened. The system worked, not because someone bought a factory part, because someone understood deeply enough how the electronic communication actually functions to give the system what it needed without giving it what Bugatti wanted to sell. That kept happening throughout this project. The manufacturer building walls. The team finding doors. Meanwhile, the car itself was being transformed visually. The Mansory aluminum panels on this Veyron had oxidized badly. Years of neglect had turned them from showpiece bodywork into something that looked like it had spent a decade in a field. Bob, the bodywork specialist on this build, treated those panels with the kind of attention that belongs in a completely different industry. Hammering, heating, cutting damaged sections out entirely. welding new material in, then working through polishing compounds for hours methodically, surfacing the metal from the inside out until the finish came back. Before and after shots of those panels looked like two entirely different cars. It was one of the most dramatic transformations in a rebuild full of dramatic transformations. Then came dry ice blasting, a cleaning process that strips decades of accumulated grime off surfaces without touching the material underneath. What it revealed surprised even the people working on the car. Beneath everything, beneath the neglect and the contamination and the abandonment, the Veyron structure was remarkably intact, remarkably original. This car hadn't just survived its years off the road, it had survived them well. The car was beginning to look like what it always was, a multi-million-pound hypercar, gleaming, complete, ready. There was one problem nobody could solve in advance, one unknown that couldn't be tested on a bench or verified in a workshop: the clutch. During the rebuild, the original friction material inside the clutch assembly had been replaced with new plates manufactured to specification. They looked correct. During stationary tests, the engagement felt smooth. But Rob and Andrew, the former Bugatti and Ricardo engineers who worked on the Veyron's original development, delivered a warning that stopped the team cold. Clutch friction material, they explained, can behave perfectly under controlled, low-load conditions. Static tests tell you almost nothing. What matters is how that material behaves when real engine torque is introduced at speed. The heat, the rotational forces, the pressure of an actual drive create conditions that a workshop floor simply cannot replicate. And if that friction material failed under load, the consequences wouldn't just be a slip. The damage could cascade through components that have no independent supply chain whatsoever. You can't know until the car actually moves, and once it moves, you're committed. Rob took the wheel for the first drive, not to take the moment away from Mark, but because Rob's hands have more hours of Bugatti clutch experience than almost anyone on the planet. If something was going to go wrong, the person most likely to catch it early, to recognize the first signs before they became catastrophic, was the engineer who helped build the system in the first place. The early feedback was everything anyone could have hoped for. Clutch engagement felt right. The bite point was where it should be. No hesitation, no warning lights, no vibration from the drivetrain. Rob described the initial behavior as encouraging. The car pulled forward. It moved with the authority you'd expect from a 1,000-horsepower machine that finally has somewhere to go. For a few seconds, this looked like the ending everyone had been working toward. Then the revs climbed, and the speed didn't follow. Nearly 500,000 pounds invested. Every sensor hunted down. Every proprietary wall climbed over. Every impossible problem solved with magnets and ingenuity and sheer refusal to quit. And the clutch, the one component nobody could test until it was too late to test it, had just reset the clock on everything. But here's what matters. This team has solved problems that Bugatti's own dealer network wouldn't touch. They've found parts the manufacturer pretended didn't exist. They've kept a car alive that every reasonable person would have written off as scrap. A slipping clutch is a problem with a solution. It's a painful, expensive, time-consuming solution, but it exists. Mark Maccan is not done. This Veyron is not done. And if Bugatti thinks a failed friction plate is going to be what finally kills this project, they clearly haven't been paying attention.